3.2 Solving Quadratic Equations by Factoring. So let's unpack this title a little bit because it'll give us clues as to what exactly we are doing today. Solving. So far in the course we've reviewed how to solve linear equations, and you're going to notice today that there are a lot more equal signs. That's because we're not simplifying expressions, we are literally figuring out what x or y equals. In the case of today, we're going to just be dealing with one variable, so we're going to figure out what x equals. So just to revisit what we were talking about before, a quadratic equation is one of the form y equals ax squared plus bx plus c, where a, b, and c are real numbers. Real numbers, and they cannot equal 0. It sounds like a bit of a fake thing, like what are unreal numbers? There's literally a system of numbers called the imaginary number system, and it's all based on the square root of -1. Think about it. The square root of -1. What? That can't happen. But in the imaginary number system, it can. When we're talking about real numbers, we're talking about how a, b, and c can be 2. They can be 1/2. They can be pi. They can be phi if they want. But they have to be a part of the real number system, meaning that they have no part in this whole square root of -1 thing, or the variable that we use is I. So please note though, if a equals 0, think about it, then this whole quadratic equation becomes bx plus c. So the degree is 1, so that means that it's a linear. So there's no way that a can be 0, because then it takes out the x squared term, which is what kind of defines it as a quadratic to begin with. So some examples of quadratics: y equals 2x squared plus 3, y equals negative x squared plus 7, or just y equals x squared. We've been factoring trinomial quadratics, so they can have 3 terms in it. Think about it, can a quadratic have 4 terms? Think about it and let me know what you think. Quadratic equations cannot always be solved by isolating the variable. One strategy is to solve by factoring. So for example, this right here, since there are only 2 terms, if we would say y equals 0, or if I just write this one right here, 0 equals negative x squared plus 7, we would be able to isolate the variable. However, when we have something that looks like the first example, when we have an x squared and an x, we can't just isolate it to one side. We have to do something else. So this strategy depends on the zero product property. That is, if a times b equals 0, then a equals 0, or b equals 0, or a equals b equals 0. So let me just show you something. If I said 6x equals 0, that means that x has to be 0. Because there's nothing other than 6 times 0 that will bring it to 0. So whenever one of the factors is 0, then the answer here is 0. So if I were to say, you could keep that written down if you wanted, if that was helpful. So if I have x times y equals 0, I know a few things. You can say that x equals 0, because if I substitute an x here, 0 times y is 0. Or I could say y equals 0. X times 0 is 0. Or we can say both of them, x equals 0 and y times 0. And in that case, 0 times 0 is still 0. Okay, so we're going to use this fact in helping us solve for quadratics. So first things first, factoring is only one of the many tools that you will be learning this unit in how to solve quadratic equations. So first things first, let's factor this. Now I know that this is a perfect square trinomial because I have x plus 3 equals 0. How do I know that? 3 times 3 is 9. 3x plus 3x is 6x. So I'm going to get x plus 3 squared equals 0. So that means that the only thing that will bring this bracket to 0 is if x equals negative 3. Here's what I mean. 0 squared is 0. So if I would say x plus 3 equals 0, or if I even say squared equals 0, I can take the square root of it, square root of both sides. X plus 3 equals 0. I'm going to subtract 3 from both sides. X equals negative 3. I know that to be true. What's really great about factoring is that you have kind of isolated the variable twice. Because if we use the zero product property, we know that each of the factors could be 0. And in each factor, you have kind of like a linear term, even though the whole equation itself is not linear, but they're linear factors because it's only of degree 1. So I've done the solving bit, so let's verify it. That means if I substitute in for my left-hand side and my right-hand side, this should be reminiscent a little bit of grade 9. Left-hand side, right-hand side. I can just say my right-hand side is 0. Boom. But now what I want to do is I want to substitute each step of the way. Now this is going to be really helpful because it will remind us of some important exponent rules. So negative 3x squared plus 6 times negative 3 plus 9. So there's BEDMAS practice, or order of operations practice, embedded right in there. So negative 3 squared is going to be positive 9. 6 times negative 3 is negative 18. And plus 9. 9 minus 18 is negative 9 plus 9 is 0. Woohoo! Left-hand side equals right-hand side. And we have verified. Let's see if we can do the same thing here. Now I'm going to do my happy, happy dance of joy here. Why? Because a equals 1. Okay, I can very quickly factor here. Now formatting here is very important. You want to make sure that you keep the equals 0, otherwise it's not an equation anymore, it's an expression. And we have graduated from simplifying polynomial expressions to solving polynomial or solving quadratic equations. So we got to think of two numbers that multiply out to negative 21 and add up to positive 4. While I'm thinking about it, I'm going to set this up. I know that one of them has to be negative and one of them has to be positive because we have a negative product. So I know that my overall number is going to be positive, so my bigger number is going to be my bigger number is going to be the positive one. So plus 7 minus 3, because 7 times negative 3 is negative 21. 7 minus 3 is 4. Bam. So now this one was easy because we only had kind of one value for x. This one's going to be a little bit more difficult. We have 2. So we're going to take this two different ways. We can say that x minus 3 equals 0, therefore x equals 3. We can say x plus 7 equals 0, therefore x equals negative 7. Now I hope that you guys get to a point where you can just look at this and say, oh, x equals positive 3 and x equals negative 7. Now might not be that time. You might need to write it out a little bit just to jog your memory on how to do it. But you can absolutely go from this step here to x equals positive 3 and x equals negative 7. So now we need to verify twice. So if x equals 3, left-hand side, right-hand side, and I would say 3 squared plus 4 times 3 minus 21 is 0. Thank you, right-hand side. 9 plus 12 minus 21. 9 plus 12 is 21, minus 21 is 0. Woohoo! Let's verify that negative 7 though. X equals negative 7. Left-hand side, right-hand side, and we have negative 7 squared plus 4 times negative 7 minus 21, and right-hand side, thank you mathematical gods, 0. Negative 7 squared is going to be positive 49 because the base is negative, and it's multiplied by itself 2 times, minus 28 minus 21. So I'm just going to do this a little bit backwards here. Negative 28 minus 21 is literally negative 49. So 49 minus 49 is 0. Left-hand side equals right-hand side, and we're done. So at the end of the day, it's going to be really important that we accept both of those answers. Say we got a left-hand side did not equal right-hand side. Item number 1. You should double check to see that you did your math right. Item number 2. You should, if it doesn't actually produce a correct answer, you have to reject it. That's one of the that's an important piece of the marking scheme for your next year's grade 12 pre-cal. So it's on the provincial exam. So it's very important actually that you literally cross out an incorrect or a not real root.